Tools let agents search, query databases, call services, and take actions beyond the model itself. I'm Mehrdad, and today we're looking at the engineering behind reliable tool use and routing. The important distinction appears when we move from a single call to a real workflow. Producing one clean function call is largely solved, but keeping many calls reliable across changing state is not. The model supplies each decision, while the harness manages selection, sequencing, validation, and recovery around it. This video explains how to engineer that surrounding tool layer. The familiar function calling demo makes tool use look effortless because everything happens inside one carefully bounded exchange. One request produces one call, one result, and one polished answer, with almost no state to manage. Real tasks stretch across many calls, while data, permissions, and intermediate decisions keep changing underneath the agent. It may choose the wrong tool, invent an argument, repeat completed work, or lose the required sequence. Those failures do not prove the model cannot call functions. They expose weaknesses in routing, coordination, and recovery. The hard part is the tool layer around each call, especially when a production agent faces hundreds of overlapping choices. It must select the right capability, satisfy its schema, and preserve valid state while conditions change between steps. The same layer must recognize when no available tool fits, then choose a direct answer or clarifying question instead. After a failed call, it needs bounded retries, useful error handling, and a recovery path that preserves prior work. Valid structured data only solves one event, so the broader question is whether the system can route, abstain, and recover over many turns. The Berkeley function calling leaderboard makes the gap between isolated calls and dependable workflows visible. Models perform strongly when one prompt requires one well-formed call with a clear tool and stable inputs. Multi-turn and agentic tasks add memory, dynamic decisions, error recovery, and coordination across a much longer horizon. The same model can therefore look capable on the first bar and surprisingly fragile on the second. That is why the benchmark gives substantial weight to multi-turn and agentic categories, where system behavior matters most. A function call is one event, while a reliable workflow is an engineered sequence of events. More available tools do not automatically create a more capable agent because the catalog imposes costs before useful work begins. Every exposed schema consumes context, and the system pays that tool's tax again on each model turn. Similar tools also compete for attention, which lowers selection accuracy and makes invented arguments more likely. Eventually, the catalog becomes noise inside the working window instead of useful capability for the current step. This is the context wrought from video 8, now expressed through tool definitions rather than conversation history. Dumping the entire catalog into every request becomes both expensive and unreliable as the system grows. The scalable move is to treat routing as retrieval, with the complete tool catalog indexed outside the active context. For each step, search that index using the current intent, then load only the few schemas that genuinely match. Approaches like RAG-MCP and MCP-Zero follow this pattern through on-demand discovery. Tool search gateways apply the same mechanism at the infrastructure boundary before schemas reach the model. This sharply reduces token cost while giving each remaining tool a clearer reason to be considered. Context curation selects useful information, and tool retrieval applies that same principle to the actions an agent can take. Two quieter failure modes remain even after retrieval improves the initial routing decision. The first is schema sensitivity, where small changes in names, types, descriptions, or ordering can produce different behavior. Stable contracts, precise descriptions, and strict validation therefore matter much more than a simple integration demo suggests. The second failure is unnecessary tool use, because agents often call something whenever the prompt rewards visible action. Sometimes the correct response is a direct answer, while other situations require a clarifying question before any action. Reliability means choosing the right tool in the right shape and confidently making no call when nothing fits. Model Context Protocol gives agents a standard surface for reaching tools through one consistent integration pattern. That standard can unlock a broad ecosystem of capabilities, but it also expands the system's operational risk boundary. Every connected tool adds permissions to manage, failure modes to contain, and potential attack surface to monitor. The standard simplifies connectivity, but it does not provide governance for the actions flowing through that connection. You still need scoped access, approval rules, audit trails, safe defaults, and clear ownership for failures. Reach and risk grow together, so every new connection represents both added capability and added responsibility. Tool use is a layer you engineer, rather than a feature you enable with one configuration switch. Routing controls which actions enter context, while schemas define how those actions are expressed and validated. Abstention prevents unnecessary or unsafe calls, and recovery keeps one failed action from ending the entire run. The model provides intelligence for each individual decision, but the harness turns those decisions into dependable behavior across time. Reliable action emerges only when routing, contracts, validation, permissions, and recovery operate as one coherent layer. Here are the 3 takeaways to carry into your own agent architecture. First, single-turn function calling is largely solved, while multi-turn routing, changing state, and recovery remain the real bottleneck. Second, routing works best as retrieval, with the full catalog indexed externally and only relevant tools loaded for each step. Third, reliable systems either call correctly or abstain, supported by strong schemas, validation, permissions, and recovery around every action. A standard surface expands useful reach, but the governance work expands with it. Engineer the tool layer instead of treating reliable action as a switch you can simply turn on. If this series is useful, subscribe to Multi-Agent Academy and connect with me on LinkedIn. Video 11 introduces skills as procedural knowledge that the harness loads only when a task needs it. Skills are not tools that perform actions, and they are not memory that preserves state across sessions. They form a genuinely new harness component, and we will separate those boundaries clearly in the next video. I'll see you there.